Hey everyone, in this third episode of Bash, we will talk about file paths. They are like addresses to the files and folders on your computer, and it helps your computer locate them. Now, before we get into the episode, I wanted to tell you about an online book that I have been working on, which this channel will be based off of. The hope is that there will be multiple books that go into various topics in depth, and these videos on the YouTube channel will have the same content, but will be more conversational and hopefully easier to follow. What I recommend for you to do is to go to my YouTube channel, go to the About section, and hit on the link that says Bash Book. This will take you to a page that looks like this. This is the online book that we will be using. You can go to the next page using the arrow on the right, like so, and you can go back using the left. You can also do this with the keyboard key left and right. You can also navigate to and from different chapters with the table of contents on the left. And the default theme is dark, but if you prefer a white background with black font, you can do that by using the what's shown here. But today's episode will use chapter 2. Alright, let's get started with the episode. Now, when I say directory, know that it means the same thing as what we know as folder. A directory is a term that programmers use much more frequently than folder. That's why I will try to use the word directory throughout this episode to get you used to that word. Now, recall that file paths are used to locate files and directories on your computer. They are like addresses. So instead of saying there is a file called f1.txt in a directory called d1, you can simply just say d1/f1.txt. Now, given a file path like d1/f1.txt, the slash here means a directory separator. It's used to basically say that what follows it belongs inside of what comes before it. So in this case, it's used to say that f1.txt belongs inside of d1, meaning f1.txt is a file that is inside of the directory d1. And similarly here, so the slash here means that d3 belongs in d1/d2, which is just another directory. So paths like d1 or d1/f1.txt, these paths are what's known as relative paths. To understand why they're called relative paths, let's look at how your computer uses the paths to actually locate the files. When your computer sees paths like this, it chunks it up based on where there are slashes. So in this case, it sees d1 first. So the first step is to find the directory d1, and then from inside of d1, it tries to find f1.txt. So here is where the idea of relativity comes in. So earlier we said that your computer first looks at d1 and tries to find the directory d1. Well, where is d1? Well, the answer is your current directory, which basically just means the directory or folder that you are in right now. There's another way to write paths like this that makes this idea more clear, which is to put a // in the front. And the dot here means current directory. It's just like any other directory. So now it's a bit more clear what your computer actually does. The first thing it does is it finds dot, which is your current directory, and from inside of your current directory it finds d1, and then it finds f1.txt. Let's look at an example of what we just talked about. So here I have two directories called d1 and d2, and inside of d1 you see that I have f1.txt, and inside of d2 there's nothing. So if we go back to where we first started, right here, which is where we can see d1 and d2, what is the file path to the file f1.txt that we just saw? Well, it's d1/f1.txt, because we first have to go into d1, and then we have to look for f1.txt. You could have said ./d1/f1.txt, because technically you are looking in your current directory first to find d1, and then looking for f1.txt. Now suppose that we go into d2, like so. Now, what is the path to the same file f1.txt, but from here, inside of d2? We know that we have to go up into the other directory first, and then look for d1, and then look for f1.txt. But how do we communicate this idea of going up a directory in Filepath? we use dot dot. Just like how a single dot represented the current directory, two dots means the parent directory, which is the directory that contains your current directory. So this is what the file path would look like to find the f1.txt from inside of D2. You say go up a directory and then find D1 and then you find f1.txt. Alright, let's now try this in terminal. So let's go back to my YouTube channel, go to About and click on Bash Book, and then let's go to chapter 2.2, which says use demo using terminal. Now Windows users should open up Git Bash, and Mac and Linux users should open up terminal. And if you haven't checked out my previous video, which was about Bash setup, make sure you run echo $0 like I am doing on the screen, and it should print something that ends with bash. If it doesn't, type in bash -- login, and if you do echo $0 again, it should say something that ends with bash. Before we get started writing code, I wanted to give you an idea of how the book is structured so that you can follow along the video as easily as possible. If you scroll through, you'll see blocks that look like this, like make dir D1, and there's another one here, it says, something like that. These are commands that I will type into the terminal that I also want you to type into the terminal. There are roughly 3 ways to use these code blocks. The first way is to just go to your terminal and type it in yourself, like this. You type ls dot and then you hit enter. Another thing you can do is you can drag and Command C, Command V, and copy and paste it into your terminal. And the easiest way, which is what I recommend, is clicking this copy button and just pasting it into your terminal like so. Sometimes these code blocks will have multiple lines of code. All that means is that you run them separately. You run the first one and then you run the second one. So in this case, I type ls, enter, which is the first command, and then I do ls dot, which is the second command. And lastly, there are code blocks that have hashtags in them, like here. So everything that follows the hashtag character, including the hashtag itself, is a comment. It's ignored by bash. So when you see blocks like this, you should ignore everything that follows hashtag. Just read it because it's a description. But when you go to type commands into your terminal, you should only type in what is not a comment. So in this case, touch and make dir. And finally, let's start writing commands. Just keep in mind that you can type clear at any point to clear the content of your screen if it's getting clogged up. I'm going to have a file browser. In Mac, it's Finder. In Linux, I'm pretty sure it's just called File Browser, side by side, so that we can keep track of what our terminal is doing. The first thing we're going to do is we're going to go to the setup section of the book that I just showed you, copy that command, and just paste it into the terminal. Don't worry about exactly how this command works. All it does is it creates a folder inside of your downloads folder in your home directory. So let's go to the downloads folder and go to the Rusty Choi folder, and that is where this episode will take place. So because of the command that I had you paste, we're already inside of Rusty Choi, inside of your terminal. So let's first type ls dot. The ls command is a way to see what's in some directories. So when you type ls dot, that's like asking your computer to show you what is inside of the directory dot, which is the current directory, which is the folder Rusty Choi inside of the folder downloads. Now, you can also write just ls without the dot, and it just assumes that you want to see what's in your current directory. It didn't print anything because there's nothing in your current directory, so no worries. Now let's go ahead and create something. So let's type make dir d1. Make dir comes from make directory, and just like what it sounds like, it makes directories. It creates a folder for you. So in this case, we're asking the computer to create a directory called D1 in your current directory. And you can see that D1 just popped up. This is why I wanted to have the terminal and the file browser side by side so we can keep track of what's happening in real time. Let's create another directory, this time called D2. Now, directory paths can have a slash at the end. It's optional, so having it, not having it, it's the same thing. And another thing is that what we write after make dir, which is D1 and D2, These are paths at the end of the day, so having the dot slash in the front is also optional and means the same thing, because when you say make dir d2, you're saying make me a directory called d2 in the current directory, and when you write make dir dot slash d2, it's the same thing, but it just makes it more explicit that you want it in the current directory. So d2, d2 slash, dot slash d2, dot slash d2 slash, they're all the same things. Now if you ls dot, you can see that we have d1 and d2, which reflects what is actually in the folder Rusty Choi now. Now let's create a file. To create files, instead of make dir, you have to use a command called touch. So in this case, we say touch d1 slash f1.txt. This is to say that we want a file called f1.txt inside of the directory d1. So if we go into d1 now, we can see that there is f1.txt now. If we run ls, it will show that d1 and d2 are in the current directory. This is because we're still in the folder Rusty Choi instead of in d1. So we can also do ls d1, which is to say, show me what is inside of the folder d1. You can also do ls d2, and there's nothing in there. Now, just like how we clicked on d1 and went into that directory, you can do the same thing in terminal. You use the command called cd, which stands for change directory. So if we do cd d1, now we're inside of the directory d1. So if we do ls to show the content of the current directory, it says f1.txt. This is because we're inside of d1 now. And recall that dot dot stands for the parent directory. So if we do cd dot dot, this brings us back to the parent directory, which is where we first started. Now, if you're in Rusty Choi and you want to see everything in your current directory, ls is kind of a pain because you have to do ls d1 and ls d2 in order to see what's inside of the directories that are in your current directory. There's an easier way to do it, which is to use the find command. So you type find dot, and you can see that it lists every file and directory that's inside of your directory. But the point is that when you run find dot, it shows you everything. That's nice and easy. You can also run find dot slash, which does the same thing. I usually prefer to use find dot because the double slash there looks a bit weird. I mean, it means the same thing, but it doesn't look as clean. You can also write find d1, which is to show everything inside of the directory d1. The same thing with d2. So far, we've learned to create files, but we didn't learn to delete them. So to delete files, you use the rm command, which just means remove. So you can see that f3.txt popped up there, but you can run rm f3.txt, and that will remove that file. You can do the same thing with directories. So create a directory d3, and let's try removing it with the same command. Where it throws an error, says that it's a directory. So to actually remove directories, you can't just use rm. You have to use a special form of it. You do rm-r d3. The -r allows you to delete directories. Now let's go to the next chapter. There is a place where you can copy these commands, but I'm just going to write them down by hand. It just creates a lot of directories and files to set us up for the next exercise. Now when you're done creating them and you run find dot, you should see something that looks like this. If you see something extra, feel free to remove it. If you don't have something, make sure to run touch and make your commands to make sure that the result of running find looks like this. Now here's one subtle note that I wanted to mention, which is when you run commands like make dir and touch, they expect that the parent directory of the path you just gave already exists. So for example, when I run touch d1, d3, f2, it expects that d1, d3 exists. And same here, it expects that d2 exists. So if we try running something like make dir d4, d3, keep in mind that d4 does not exist. If you run this, you will see an error that says d4, no such file or directory. So this just goes to prove the point that the parent directory has to exist. It's the same thing with touch d4, d5, f3. There is no d4, d5. In this case, the error message is less helpful, but it's basically from the fact that the parent directory of f3, which is that d4, d5, doesn't exist. Now, the last thing I wanted to talk about for today is the shortcoming of relative paths. So consider a scenario where your friend tells you that they left you a file called d3/f2.txt. Here's the problem. There are two files that your friend could have meant by d3/f2.txt. The problem with relative paths is that it's relative to where you are, and where you are might be different 5 minutes from now or an hour from now. So it's not a great way to specify files because it assumes that people know where you were when you wrote down that relative path. So here's what your friend could have done to make your life easy. If your friend wanted to talk about the file d1 d3f2.txt, they could have used a command called realPath. If you do realPath and specify a file, it will print a path that looks like this. Now, you might notice that this path is slightly different from all the other paths that we've seen because it starts with a slash. So slash usually means a directory separator, but when that slash is put at the very front of the path, it means something different. It means the root directory. The root directory is a special directory. There's only one of it on every computer. And think of it this way. If you were to find the parent directory of any file and find the parent of that parent and repeat this process, every file eventually ends up tracing back to the root directory. So you can think of it as a parent directory of all files on your computer. And when file paths start with the root directory, these are called absolute paths because they have an absolute starting point of the file path, which is the root directory. And the advantage of it is that because the file path search starts from the root directory, which everyone knows where root directory is, there's only one of it on your computer, so anyone reading your absolute path will end up at the same location, unlike relative paths. And a cool little side note, if you ever want to know where you exactly are, you can type realpath dot, which shows you the absolute path of your current directory. This is the same thing as running this command called pwd, which means print working directory. They're the same thing. If you followed the bash setup video, which is the last video, your terminal will look like mine, and you'll notice that every time I went to type a command, there's a line right above where I enter the command, which you might have noticed is a path to the current working directory. This brings up another point, which is the squiggly character right at the front. So just like how the character slash by itself is used to denote the special directory called root, you can use that squiggly character, which is called tilde, and it represents your home directory. Your home directory usually has the name of your operating system user. So for me, it's Jack W. Choi. And this directory is special because this is what contains like 95% of every file and directory you'll ever touch, like the desktop folder or downloads folder. These are all inside of your home directory. So just to save time, instead of having to type -users your username, you can just type tilde and your computer knows where you're talking about. And that's it for today's video. At the end of every chapter in the book, I will have some sample problems ready in case you want to test out your knowledge and your understanding of the content covered in the video. But otherwise, thank you for watching. And if you have any questions, feel free to leave them in the comments and I'll do my best to answer them.